Friends, welcome to ZimSIC Robotics Lab with the Zim Science General. In this video, we are going to discuss robot design methodologies. We are going to focus on identifying tools and applications for robot design, and we are also going to use tools and apply applications for robot design. Robot design is creating a robot's physical appearance and defining its functions. It follows several steps which will be discussed below. There are 4 components of the design process, which are mechanical design, which involves the design of the robot's physical structure. Then we also have the electrical design, which is responsible for designing the robot's wiring, circuitry, and power sources to allow the robot to function. Software design, which involves the robot's programming software to allow the robot to perform necessary tasks and interact with the environment. Then we also have the control systems design, which is responsible for the designing of the robot's hardware, software components, which are needed for the robot to operate autonomously or with little or no human intervention. Then we consider the steps to be followed in robot design. The diagram shows 4 major steps, which we start with step 1, identifying the purpose of the robot and what it requires. This step answers the question, where will the robot operate, on land, space, or underwater? Then what tasks will the robot perform? Is it painting, welding, harvesting fruits, or other tasks? And at what speed will it operate? Then the conceptual design. This involves creating a conceptual model or sketches of the robot structure and building simple prototypes to test basic functionalities. You can use a computer or you can even use your hand to sketch. Then step number 3, which is a detailed now, conceptual design and simulation. This stage involves using CAD software tools like SolidWorks to develop detailed 3D robot model parts, assembling these parts together in a virtual environment and running visual tests on movements and task execution. The visual testing and validation of robotic system in the virtual environment is known as simulation. Simulations are crucial as they allow adjustments before the actual robot is constructed, saving on time and resources. This step winds up by creating a comprehensive blueprint, a detailed plan, or a program of action. Then we have the stage where a prototype is produced, which is called the prototyping and testing stage. A prototype is produced by using all components according to the detailed design, followed by tests to check integration and performance, changing the design based on the test outcomes. A prototype is the first model of a robot from which other robots are copied and developed. After the prototype has been made, it is approved Then we have the final stage where we finalize and document the design. This is the final step of preparing a comprehensive, detailed, professional documentation or a user manual that ensures that the robot's design can be replicated in the production of the actual physical robot. Then we want to consider the tools that are used in robot design or in the robot design process. The most popular tools are called CAD tools. CAD standing for Computer Aided Design Tools. CAD tools fall into software and hardware. We start with the hardware. The hardware tools, we have the input devices, which include the keyboard, the mouse, or the webcam, which is used for typing commands into the software. Then we have the output devices. The output devices are the monitor and printers, etc. Then we have the processing devices. The processing devices, the CPU. CAD software tools are numerous and they are constantly changing and changing, but these tools are very useful in that they allow accurate designs in 2D drawings and 3D models of real world robot components on the computer. Popular CAD software, we have the CATIA, the SolidWorks, AutoCAD for 2D drawings, the Autodesk Inventor, the Solid Edge, and the Fusion 360. Then, what are the key applications of CAD tools in robotics? We use CAD tools in 3D modeling. 3D modeling allows CAD tools allow the designing and creation of precise 3D models of robot parts like chest, arms, grippers. Then CAD tools also allow these robot parts to be assembled virtually to visualize how parts fit together. Then CAD tools allow what is called simulation, which is the creation of the entire robot in the virtual environment, visualizing robot movements and operations, and to test if the robot performs tasks properly before physical parts and the actual robot are built. CAD tools also allow prototyping. CAD software tools allow the creation of prototypes of 3D models of robot parts using 3D printing. Then documentation. What is documentation? Creating a comprehensive and professional digital documentation which includes detailed drawings, specifications, and assembly instructions. Then let us look at quick questions. Define a robot. List 4 components of robot design. State the purpose of the first step in robot design. What is the importance of simulation